Okay, so the next concept will be called the critical angle. So this critical angle is the most critical concept of all, especially in this chapter. So of course, what is critical angle? So critical angle is the angle of incident that cause the angle of refraction to be 90 degree from normal. So I understand that, I say the angle of incident is always in the less dense medium, but angle of refraction is always in a more dense medium, right? But for now, we try to relax on the assumption. So okay, so if you look at this light, right, this diagram, so you notice one thing, right? When the light hits the glass air boundary, so by right, the light should go into the air, and of course bend away from the normal, because the speed of light should be faster in the air, right? But when the light hits at a certain angle called the critical angle, right, the light actually will travel on the boundary of the glass block. So that is a very important concept. So every object has its own critical angle. So for example, how do we calculate your critical angle? So you must use this formula of sine c equal to 1 over n. So what is c? C is known as your critical angle. So of course, n is your refractive index. So looking at this, right, how do I calculate the critical angle of a glass? So for example, I know that my glass has a refractive index of roughly 1.50. So let's do a bit of calculation here. So sine c, just take note that c here is the critical angle, not the speed of light. So sine c is equal to 1 over n, right? So what is 1 over, what is the n? N is 1.5. So you just sine inverse. So critical angle is equal to sine inverse 1 over 1.5. So it's equal to, let's say, 1.5. So it's roughly about 41.8 degree. So that is how we calculate the critical angle of a certain material. Okay. So let's go on to the next part. Okay, so what if my angle of incidence right now is more than the critical angle? So something called the total internal reflection will occur. So this will the light will not even enter the air. It will just reflect, something like your mirror. So it just reflect. But the thing is that we must fulfill two conditions. So the very first condition will be that light must travel from optically denser medium to less dense medium. So we must travel from, for example, I must travel from glass to air. Cannot vice versa. Vice versa will not happen. Okay. Number two will be the angle of incidence must be greater than critical angle. So for TIR to occur, you must be greater, not equal, not less, but greater. So that is the meaning of your TIR. So looking at this diagram, right, you can see that total internal reflection actually occurs already, because from glass, right, the light hits the boundary. Since it's greater than your critical angle, you will undergo TIR. So it's something like a mirror like that. Okay, so of course, you can pause this video while I go through you can pause this video and you try the checkpoints. After that, when you finish doing the checkpoints, you can play this video again. Okay, checkpoint 6, let's go through. So we have this diagram showing a right angle prism being able to turn a ray of light through 90 degree. What is the critical angle for the light in the glass? So it's a 2012 O-level question. So definitely you undergo total internal reflection, right? So you must, this angle 45, so angle 45 degree is not equal to critical angle, because if it's equal to critical angle, the light will travel in this direction. So you travel on the boundary of the prism. So cannot be 45. So this 45 degree is definitely greater than your what's it called, the critical angle. So the answer for this should be okay, so 45. Okay, so they say what is the critical angle for the light in the glass, right, is less than 45. So that is the critical angle. So critical angle, for example, in this context, right, maybe the critical angle is 43. since my angle of incidence here is 45, so 45 is greater than 43, I will undergo total internal reflection. So another thing to take note when you're doing checkpoint 6 is that at this particular part and this particular part, there shouldn't be any reflection because you are actually perpendicular to the surface of the prism. Okay, so just take note of these two things. Okay, now I move on to checkpoint 7. So it's a 2016 O-level question. So which row shows the description of the refractive index and the critical angle? So okay, what is refractive index? Refractive index is the speed of light in vacuum. So on this actually a ratio or a fraction. So on the top, the speed must be greater. At the bottom, the speed must be slower. So if you look at A is wrong. B is also wrong. Okay, C seems fine. D also seems fine. Okay, let's take a look at critical angle. So critical angle is actually the maximum angle of incidence for which refraction can take place. Yeah, so this is option C. So what is D? D is the minimum angle of incidence for which refraction takes place. This is actually wrong. Okay, so the answer for this will be Canada. Okay, let's move on to checkpoint 8. Checkpoint 8 is a 2018 O-level question where we have a ray of light passing through the side of glass tank into water. So the ray enters the water at X where it is refracted. At Y, most of the light is reflected. So highly likely this is total internal reflection, but some refracts along the water surface. So which diagram shows the angle of refraction at point X and the critical angle at point Y? Okay, so first thing first, if you look at let's dissect this question. If you look at the light ray initially is in air. So when you enter the glass, right, you actually bend towards a normal, which is consistent. Then after that, you hit X, right? You hit X, you notice one thing is that the light bend away from the normal. So this tells me that glass has a higher refractive index than the water. So of course, you go and hit point Y, right? So point Y is here. So always draw a normal. So you draw a normal, you notice that most of the light will reflect into the water and some of the light will travel on the water surface. So this I can safely say that okay, this is critical angle lah. So they say that which diagram shows the angle of refraction R at X. So the angle of refraction is right here, R. Okay, so the answer for this is not A, because A, you notice that my angle of refraction is not with respect to the normal. So if you look at B, okay, B, this is wrong because the critical angle shouldn't be right here. Okay, C, also wrong because the angle of refraction is not with respect to the normal. Okay, D, the angle of refraction is here and the critical angle is here. So this is correct. So it's Denmark. Okay, so let's move on to checkpoint 9. So checkpoint 9, we have this light traveling from one medium towards a less dense medium. It is refracted along the boundary between the medium as shown. Which angle is the critical angle? So this is quite simple. Always look at the normal. Then is the angle between the light ray and the normal right here. So the answer should be Canada. Okay, so checkpoint 10. So this one is a bit challenging. So if this glass prism, right, with angle 45, 90, and 45. So this is your isosceles triangle. So the next thing is the critical angle for glass is 42 degrees. So narrow beam is directed onto the prism. Which arrangement shows the beam undergoing TIR twice before any light leave the prism? So let's take a look at option A. So option A is the light ray right in air. So you enter perpendicularly to the glass surface. So apparently there shouldn't be any refraction. So let's draw. Okay, so of course you enter. After that, you hit this particular point. So I want to draw a normal. So to tell me what is the angle of incident right here. So let's draw a normal. Okay, so this one you will need a bit of the so-called the maths lah. So maths. Okay, so for the I draw here. Maybe I draw here because need some space. Okay, so I have this light hitting the surface, right? So this is 45 degree. Then after that, you go hit the surface. Okay, so you draw a normal right here. Okay, so apparently this is 45. This must be 90. So this is 45. So the angle of incident here is 45 degree. So this is 45 degree. So this is greater than your critical angle. So you must undergo your total internal reflection. So you draw here. Okay, so you draw here. Then after that, you draw another normal. So you draw another normal here. Okay, so 45. So this must also be 45 because the angle of incident is equal to the angle of reflection. So since it is 45, right, we know that, okay, normal is 90 degree, right? So this is also 45 degree. So this is 90 degree. This is 45 degree, right? So the next thing is I want to know, what is the angle of incident at this particular point. So at this particular point, we know that the angle of incidence is 45 degree. So this will also undergo total internal reflection. So this you just reflect again. Then after that, you exit the prism perpendicular to the surface. So in this case, right, you know that you can see that my light actually undergo two TIR. So the first will be right here. The second will be right here. So the answer is option A. A for Argentina. Okay. So yeah, so these are all the different checkpoints. Okay, so yeah.